Lesson 5, Transformations in the Coordinate Plane. Your learning targets for this lesson are to identify reflections, rotations, and translations, and graph transformations in the coordinate plane. Your vocabulary words are transformation, reflection, pre-image, rotation, image, and translation. The Alhambra, a 13th century palace in Granada, Spain, is famous for the geometric patterns that cover its walls and floors. To create a variety of designs, the builders based the patterns on several different transformations. What is a transformation? It is a change in the position, size, or shape of a figure. The original figure is called the pre-image. The resulting figure is called the image. A transformation maps the pre-image to the image. We use arrow notation to describe a transformation, and prime numbers, or the little apostrophe mark, are used to label the image. For example, the pre-image triangle ABC has been moved over, just slide it over a little bit. This is a transformation, and we have used this to map triangle ABC onto triangle A prime, B prime, C prime. Three kinds of transformations you need to know are reflection, rotation, and translation. A reflection is like a mirror image. It can be flipping your shape across the y-axis or across the x-axis. Your image will end up being the exact same distance from the line of reflection as your pre-image was. A rotation is like turning it around, such as when we hold the camera sideways and then we want to flip the picture so that we can print it right side up. A translation is just a slide, or like moving a box from one place to another. You're moving all the points in the same order and the same distance from their original location. Let's try one. Identify the transformation, then use arrow notation to describe the transformation. As you can see, we have triangle ABC here, and we have a triangle A prime, B prime, C prime. And we want to try to figure out what kind of transformation this is. It can't be a reflection because each point and its image are not the same distance from the line of reflection. This would be a 90-degree rotation. Since A looks like we could have slid it down in a slide or a translation, but B and C have been moved and their position. Therefore, we know that we have rotated the triangle so that C is the top vertex. Let's try another one. If we look at the pre-image D, E, F, G, and D prime, E prime, F prime, G prime, we see that DE and D prime, E prime are mirror images of each other. It looks as though we are seeing a reflection in the water. This transformation cannot be a translation because each point and its image are not in the same relative position. We have turned this upside down, so this would be a reflection. Now you try. Did you say that A was a translation, we have simply moved the rectangle over. What about B? If you said that B is a rotation, you are correct. We have turned this triangle around. A figure has vertices at A, 1, -1, B, 2, 3, and C, 4, -2. After a transformation, the image of the figure has its vertices at A prime is -1, 1, B prime is -2, 3, C prime is -4, 2. Let's draw the image and the pre-image and identify our transformation. First, we're going to plot the points and use a straight edge to connect the vertices, like this. If I look at these two triangles, and I'm sure you see it, they are mirror images of each other. This would be a reflection because it has been reflected across the y-axis. Let's try another one. We are given that we have a shape EFGH and E prime, F prime, G prime, H prime. Let's draw the pre-image and the image according to the vertices we were given. And we see that we have EFGH. Over here we have EFG and H going upward. This would be a rotation. To find coordinates for the image of a figure in a translation, you should add A to the x coordinates of the pre-image, add B to the y coordinates of the pre-image. Translations can also be described by a rule such as xy mapped onto x plus A, y plus B. For example, if we want to find the coordinates for the image of ABC after the translation xy mapped onto x plus 2 and y minus 1, we're going to draw the image. First of all, we have to figure out where our coordinates started out. The vertices are -4, 2, -3, 4, and -1, 1. Then we need to apply the rule x plus 2 and y minus 1 to each vertex. We find A prime at -2, 1, B prime at -1, 3, and C prime at 1, 0. When we draw this, we can see that we've taken our blue triangle and just moved it over. This is a translation. Let's try another one. We have a rectangle, JKLM, and we want to draw an image from the pre-image with the rule x minus 2 and y plus 4. Let's find our coordinates first, and then we apply the rule and draw our new rectangle at these vertices. Once again, we've taken our rectangle and just moved it up and over. How about an art history application? The figure shows parts of a tile floor. We want to write a rule for the translation of the hexagon 1, this one, to hexagon 2. So first we'll choose 2 points. We'll take the same point on both of them, this edge A and A prime. We find the coordinates of each. A has a coordinate 2, -1. A prime has coordinates -1 and 1/2. Now, our rule would be that we have moved over to the left 1, 2, 3 spaces and up by 1.5. So our translation is xy such that we're mapped onto x minus 3 and y plus 1.5. One final example. Use the diagram to write a rule for the translation of square 1 to square 3. We have marked a point A on each one, A and A prime. A has the coordinate 3, 1. A prime is at -1, -3. We count the units 4 units over to find where A prime would be, and 4 units down also to get to A prime. So our rule would be xy mapped onto x minus 4, y minus 4. Make sure that you've taken your notes and are ready for class tomorrow. Have a good evening.